Hey Calculus, welcome back. We are on our last day of volume today. Today we're going to be finding volume using the washer method. I've got the checklist on the screen. You know what to do from here. All right, I'm going to force another pause on the screen. Can you go ahead and copy this graph for me? All right, so let's say I want to revolve this blue region about the line x equals 3. I'm going to force another pause on the screen. Can you go ahead and draw one representative radius for me? All right, so your radius should look something like that. So each radius I'm going to rotate around is going to create a circle. So I'm going to end up summing up an infinite number of circles, right? Now, this radius, would you find its formula using top minus bottom or right minus left? This would be right minus left. So would your integral all be in terms of x's or y's? This would all be in terms of y's, right? So we would first need to take this equation here and solve it for x in terms of y. So if I square both sides, I'd get that x equals y squared, right? Okay, I'm gonna force another pause on the screen. Can you go ahead and just set up an integral that would give me this blue shaded region revolving around the line x equals 3? All right, we should be taking an infinite sum, so an integral of pi r squared. Don't forget your pi on the outside. Be really careful because you do want the domain or the range for your a and b values. You want the range because everything's in terms of y, so we should have a square root of 3 as our b value, and then doing right minus left yields 3 minus y squared, and don't forget to square that whole quantity. Okay, we're going to kind of extend this idea today because notice that with this problem, there was no empty space between your axis of revolution and that blue shaded region, right? But what if we try to take that same region and revolve about the purple line, y equals 2? Is there any empty space? There is, right? If I were to try to take one representative radius, for example, and I started at my axis of revolution and went perpendicular into my shaded region, well, I have that, but I also have all this empty space here, right? So no longer when I take a slice, am I going to get this nice whole disc, right? Do you know what I'm going to get instead? I'm going to get what's called a washer, right? If you've ever built any IKEA furniture, you know what this is. So a washer is like a donut, okay? It is a disc with a hole in it. So it's still got some thickness to it. So there's your dx or dy, depending on what variable we're using or what axis we're revolving about. But instead of, a nice disc that is that's filled in all the way, you're going to get washers for each slice because you're going to have some empty space in each slice. All right, force pause on your screen. Can you just copy the picture of the washer that I have on the left, labeling the little radius, little r, and the big radius, capital R? All right, so first we better figure out what a formula is for the area of these washers because we're going to end up summing up an infinite number of them, right? So we're going to end up taking what of all these washers? We're going to end up taking an integral, right? Because, again, all these washers are going to be different sizes. They're going to vary at various rates. So algebra fails us, which means what comes to the rescue? Calculus comes to the rescue. So we'll harness the power of infinity once again through calculus, in this case through integrals. But first, let's come back to the geometry, okay? So would you agree that if I want the area of the gray region, I would take the area of the big circle and then subtract out the empty space, the area of the little circle? All right, well, the area of the big circle is pi capital R squared. The area of the little circle is pi little r squared. So if we factor out that pi, we get pi times the quantity r capital R squared minus little r squared. Okay, so when we want to calculate the volume of a solid form by rotating a region bounded by two graphs, so an outer and an inner function, then I'm just going to take an infinite sum, so an integral, from a to b of all these washers. I'm bringing that pi out in front, so capital R squared minus little r squared, and then either dx or dy. Right, depending again on your axis of revolution. So we'll determine that exactly the same way we did disk method, okay? So this here is called washer method. Let's try a few together. All right, first pause on your screen. Can you go ahead and copy the region bounded by the graphs of f and g that I have on my screen? All right, so it says set up an integral that would revolve the given region about the following lines. So we're just doing setup only, okay? So I'm going to start with y equals 1, negative 1, I'm sorry. So I'm going to go ahead and graph that. Okay, now you want to ask yourself, is this disk method or washer method? In other words, is there any empty space between y equals negative 1, which is, again, my axis of revolution, right? And this region, this shaded region. So is there any empty space? There is. No, there's not empty space everywhere, but we do have some empty space. That tells me right away I'm going to use washer. So for washer, I need to figure out my big radius and my little radius. And that little radius is going to be the empty space. It's going to represent the circle that has empty space. So grab your pen or pencil, and we are going to, just like with disk method, always start at your axis of revolution. Now this time make sure you're starting at a place that does have some empty space. Okay, then we start here around x equals 2. Okay, so start there and go perpendicular to your farther function. In this case that would be f of x, right? So I'm going to call this capital R. That's my big radius. Okay, but notice I grabbed a little bit too much. I have all this empty space. So come back to your axis of revolution, put your pencil there for me. And this time, go perpendicular and to your closer function, this time to g of x, that is going to be little r, right? And notice that little r grabs all that empty space, so that's why I'm going to subtract out that entire area, alrighty? Okay, so capital R and little r, are they top minus bottom or right minus left? Top minus bottom, so are we in terms of x or y? We are in terms of x. So I'm going to start out with my formula. It goes pi integral. Now, would you use your x values, your domain, or your range for your a and b? Your domain. So I can tell that shaded region is going from x equals 0 to x equals 3, and my formula goes capital R squared minus little r squared. And do we want dx or dy? Dx. Okay, notice that you need to square both r's, okay? Don't do the whole thing and then square that. It is not the same thing, okay? Exponents, you cannot distribute those things, all right? Okay, so let's fill this in. I've got pi, integral from 0 to 3. All right, capital R, you said it's top minus bottom, so go to the top. That would be your red function, that's f of x, minus the bottom, which is what? It's just y equals negative 1. So capital R is going to be f of x minus negative 1, so that would be plus 1. And then remember, I have to square capital R, right? Then minus, now we're going to do the same thing for little r, so top minus bottom. So here's the top, that's at g of x. And then here's the bottom, again, that's negative 1. So I have g of x minus a negative 1, so plus 1. That's little r, and then we square it, dx. Notice you've still got your three variables, right? You've got your square for area and your dx for that tiny depth. Okay, I'm going to force a pause on the screen. See if you can do part B on your own. You either want to erase the R and the capital R and little r that we have, or redraw the area. Okay, so try B on your own, hit continue when you're ready to check your answer. All right, so it should look pretty similar to the last one. Just make sure you're going top minus bottom each time and not bottom minus top, because that's going to yield a negative radius, which we can't have, okay? So double check your answer, correct anything that you need to. All right, here's example 2. Can you do me a favor and copy this graph 3 times, because we're going to do 3 different axes of revolution, and then also go ahead and lightly shade the region that we are revolving. Hit continue when you're ready to continue. All right, so let's try part A. We're going to take this region and rotate it about the x-axis here, okay? So, do we want disk method or washer method? This is going to be disk method from last time, because notice there's no empty space between the axis of revolution and that yellow region. So, go ahead and grab your pen. And first we need to, so we'll just have one R in this case, right? So start at your axis of revolution somewhere, go perpendicular into your region. So am I going to draw up, down, left, or right? I'm going to go up, right? And this is going to be capital R, right? And we just have that one radius. Now, are we in terms of X or Y? We are in terms of X. I'm going top minus bottom, or also think of it, you have a horizontal axis of revolution, okay? So it's going to be pi infinite sum of r squared, right? Now, do you want your domain or range of that yellow region for A and B? Domain. So from x equals 0 to x equals 1, dx. All right, now we just need to fill in what r is, right? Is this the top minus bottom or right minus left? Top minus bottom, and the top is negative x squared plus 1. That was in the directions here. What's the bottom? Just 0, right? We'll square that, dx. Okay, these are just going to be set up only. All right, let's try part B. All right, for part B, we're going to rotate about the line y equals 2. So let's go ahead and draw. That would be somewhere kind of up here, right? Okay, so would you say disk method or washer method here? This one's going to be disk method, right? Because there is a lot of empty space between this axis of revolution and my shaded yellow region. Okay, so grab your pen and go in 2 colors here. Start at your axis of revolution, go perpendicular to your farther function. So you want to grab all that yellow area, okay? And then grab another color here, or another, doesn't have to be another color, but now go back to your axis of revolution, perpendicular again, but this time you should be grabbing all that empty space, right? Okay, so that first line we drew, that's capital R, and then the second one we drew is little r, right? So if we set this up, we are going to have, and by the way, are we in terms of x or y? Still x, right? Still top minus bottom. So pi integral from x equals 0 to 1. This is going to be a capital R squared minus little r squared dx, right? You don't have to write that each time, but just so you know, if it helps, so you know where things are coming from. All right, capital R, you said top minus bottom. So what is the top? The top is y equals 2, right? What is the bottom? Bottom is y equals 0. So this is going to be 2 minus 0, and then don't forget to square it. Okay, we can just make that a 4. All right, then minus, now we need to subtract out the little r, right? So what's the top for little r? Also 2, and what's the bottom? It's that quadratic, right? Make sure we've got parentheses here, or distribute the negative either way. Okay, so this is a 1. So we've got 2 minus the quantity negative x squared plus 1, and then that whole thing squared. And then all of that here is finally the period at the end of the sentence, dx. Okay, all right, let's try part C. All right, so for this last one, we want to revolve about the line x equals negative 1. Is that a vertical line or a horizontal? That's a vertical going through the x-axis at negative 1. It'll be around here. So we want to revolve about this axis. So this tells me, by the way, is everything going to be in terms of x or y? This will be in terms of y. You've got a vertical axis of revolution, which think of that as parallel to the y-axis, okay? All right, disk method or washer, 1r or 2? 2, we've got all this empty space, right? Good deal. Okay, so let's come draw both of the radii. So I'm going to do capital R first. So again, always start at your axis of revolution and go perpendicular into the region and make sure you go to the farther function. So that would be this one. Okay, and then for your little r, come back to your axis of revolution, go perpendicular and grab all that empty space, right? So let me label, the purple one is capital R, and the orange one is little r. Okay, and you said everything here is going to be in terms of x or y? In terms of y, right? So that means I'm going to need to solve that equation up there for y. Sorry, for x in terms of y. So let's see here. How about I bring the x squared over to the left side of the equation, and I'll bring the y to the right side, and then square rooting both sides, I get x equals technically plus or minus square root of 1 minus y, but I'll want the positive branch in this case. Okay, all right, so now we're going to go pi integral from y equals 0 to y equals 1. The range happens to be the same as the domain of that region. And again, this is going to, we'll have both a capital R squared and a little r squared. Make sure we're doing dy this time. So we're going from 0 to 1. All right, so capital R is going to be right minus left. So right is square root of 1 minus y. Minus, and then this is negative 1, so minus negative 1 is plus 1. So that's capital R. Don't forget to square it. and then minus, maybe, and then little r. This x value is just 0, minus a negative 1, again, will be plus 1, quantity squared, and then dx or dy? dy. Notice everything is in terms of y's. We don't want to mix up those variables. Force a pause on the screen. Can you go ahead and copy my graph? Can you shade the region we're looking at? And then can you also draw a representative capital R and little r? Hit continue when you are ready to check your graph. All right, so here is the region we are rotating. Hopefully you've got your capital R there and your little r. Again, always make sure that little r is only has empty space in it, right? Okay, so our radii, are they top minus bottom or right minus left? Top minus bottom, so what would be in terms of x or y? Will be in terms of x, so we need the domain of this yellow region. If you set these graphs equal to each other, by the way, you'll get that they intersect at 0 and 1. So I'm going to go pi infinite sum from x equals 0 to x equals 1, capital R squared minus little r squared, dx or dy? dx. Okay, so let's just come up with some formulas for capital R and little r. So you said capital R, top minus bottom. So by the way, y equals x squared is concave up, right? So if you are unsure, maybe we should label these. This is y equals x squared, and this is y equals square root of x. All right, so for capital R, we're going to go top, which is square root of x, minus bottom, which is 0, and we're going to square that. And then minus, now we're going to do the same thing for little r. So the top is x squared, minus the bottom, which is 0, and we're going to square that. And then dx, right? And we can type this all in the calculator. Let's see what this type of thing looks like. All right, here is my region. I'm going to revolve it about the x-axis here. You can see now we've got kind of a bowl again, right? But we've got kind of some empty space in here, so you can kind of see this as I rotate it. Really pretty 3D shape here, yeah? All right, so I did setup only. I didn't go through all the Math 9 again. I feel like you should be good with the calculator commands. Your entire assignment is going to be calculator active. I do have some requirements. I would want to see a graph, okay? Now you can graph it in your calculator and copy it in your notes, that's fine, but I want to see a graph for your assignment. I want you to shade the region either with a highlighter or lightly with a pencil. Please mark capital R and little r. Set up the integral that represents the volume, and then go ahead and type it in your calculator and see if your answer matches my key. All right, you all, that is all I have for today. I'll see you next time.